Hello friends, I welcome you all to this session on C++ programming, that is modeling mathematics, that was numerical method in C++. So in the previous lecture you have seen that how to evaluate the forward difference, backward difference and central difference, and you have also seen that this is more accurate in comparison to the others. So now the question is that was only for single variable. So how to do the same thing for multivariable? Now in multivariable case, as this is the function, so this function is depending on x, y and z, three variables. So what I have to do is I have to, so now if let's say that this was some plane and this is x, this is y and this is z, let's say for the time being only two variables are there, x and y, and let's say z is some function of x and y, then what we have to do is we have to look it from one direction. That means first with respect to y only, and then from other direction, that is with that means if I look it from here, then I will not be able to see this x. For a particular x, I will be able to see every scenario. Then I will be able to see one curve, and when I look it from here, that means from the y axis, then I will be able to see z and x. From here, I will be able to see y and z. Then from y and z perspective, I will be getting the derivative, that is del f by del y or del z by del y. Okay, and from here I will be getting derivative del z by del x, because y is kept constant, y is not varying, I cannot see y. The same thing we can also do here in case of this variable function, which is a multivariable function, and it is having three variables x, y and z. What we can do is we can evaluate this derivative with respect to x, then with respect to y, and then with respect to z. And here, once we evaluate the function with respect to x, what we are doing is we are not allowing y and z to change. So if that is the case, we are not allowing y and z to change, then what will happen? Only x is the parameter. Y and z can be taken as a constant. So this will simply be 2xy plus yz plus zy square. Likewise here, x square xz plus 2zxy, and here it is 0 xy plus xy square. But this is analytically. How can we do this numerically? We will be doing in the same way which we have used, or the method which we have used in the last lecture. Central difference, more accurate. Here only one variable was there, so we varied it, but right now three variables. So what we will be doing is, for first derivative we will only be changing x, for second y, and for this we will be changing z only. So if I am interested in finding out what is del f by del x, then what I will be doing is I will be changing x only. Oh sorry, and y and z will be kept constant. And this divided by 2h. Here, what is h? It is dx, dy and dz, that is increments in all the direction, and I am taking that increment to be same. What about del f del y? It is fx y plus h, and then x y minus h. That means only change y. And then finally, that is z, that is del f by del z. So it is f x y z plus h minus x y z minus h. That's it. It is so easy. So whatsoever you have done for single variable in the last lecture, the same thing we will be doing for multivariable. So let us try to solve the same function. So here, as we are doing it numerically, then we want some values. So let's say x is same as y, same as z, and that is equal to 1. So if you do it, then in principle what you should get, it is 2 plus 1 plus 1, that is 4, 1 plus 1, that is 2 plus 2, 4, and this is 1 plus 1, 2. So for del f by del x you should get 1, del f by del y, sorry, del f by del x you should get 4. Let me write it here. For this also 4, and for this you should get 2. So let us head to the code blocks. The function I have already written. It is the same function, you can check. It is x square y plus xyz, x square y plus xyz plus zx y square. So it is zx and then y square. What we'll be doing? We'll be evaluating partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. So now in this case, as we cannot write partial, so we have written only d. So df dx means partial derivative with respect to x. You can think in this way: df dy for y and df dz for z. So now, what is df dx? It is nothing but f x plus h y z. That means we are only varying x. We are not touching on y and z. So x minus h y and z, and this whole will be divided by 2h. Okay, then df dy. Now let us copy this, and this is with respect to y only, so it is plus y, and this will be minus sorry, so sorry, not y, plus h. So it is changing with respect to y, so it is, the change should only be reflected in y, not in x and z. The same thing we can do here. Df dz is with respect to only z. So change will be with respect to z. So these are what? These are the numerical differentiation, central difference way of writing the same derivative. So here this. Okay. Now once this is done, the next part is to print it. So it is what? Let me write it: df dx, and this is df dx. Copy it. Then df dy, then this is df dy, and this is df dz. So this is df dz. That's it, friends. Done. Simple. So at x is equal to y is equal to z, we require the answer, and we have already seen that it should come out as 4, 4 and 2. So let us see whether it is coming or not. So if you run it, yes, you are getting the same answer, but with truncation error, that is, it is point after so many decimal places 7 is coming. So it is almost close to 4, 4, 1. So now if you want to increase the precision, what you do? You increase the decimals here. So if you run it now, so you can see it is now 2. So if you increase the decimal further, let's see what happens, whether it increases. The answer has slightly blown up. So now one question you must be thinking, okay, we have increased the precision so much, but still we are not getting the answer. The answer is not only because of the answer is not coming exact, not because of not only because of this h, but because of the variable choice. Now if you do what? If you, instead of making float, if you take it double, okay, let us copy this, and here also make it double, and here also make it double, then the precision increases a lot. And now if you run it, then you will be able to see that you are getting exact answers as 4, 4, 2. So in my opinion, float is also okay if you are understanding the logic, but if you want the exact answer, then you not only increase the precision of h, but you can also increase the ability of the variable to hold more data. That means you should go from float to double. So in this lecture, till this point only. So in the next lecture, what we'll be doing is we will be writing the same functions but in a different way. That means we will be writing functions which are accepting some other function, so that our program can look much better. Okay, so in this lecture, till this point only. Thank you very much for watching it.